My name is John McNabb. This talk is about just a little background. I'm an IT pro. I do freelance IT tech support. Spent a lot of time doing that for a major bank that probably doesn't want to be named, and also for other businesses and homeowners. I've got a long environmental advocacy background, 10 years at Clean Water Action, 6 years at the Mass DEP. I was a water commissioner in a small town in Massachusetts for 13 years. I spoke at the Next Hope on electronic take-back, and this talk is an expanded version with added material from that talk. And at DEF CON 18, I spoke on cyber terrorism and the security of the drinking water infrastructure. There's some other background qualifications for some of the topics in this speech, such as electronics take-back, the EPA National Electronics Product Stewardship Initiative, and I've been active in solid waste planning in my area south of Boston. But just first, I'm not bashing IT. I make my living from it, and we are all aware of some of the benefits from IT in improving education, business, and communication. And this is just a way to educate folks, like us in the field about some of the negative impacts and what we can do to minimize them. And I think one of the greatest improvements to society in the world from IT has been communication, the increase in the size in complexity and use of the internet, and the, let me find that pointer I got, and the exponential growth in data transmission, which is reaching a straight line. But while all this is going on, more and more PCs and laptops and other electronic components are being produced and put in use, and they each have impacts, and that's what I'm going to be talking about. So there's a school of thought looking at environmental impacts of things that's called life cycle analysis, and I'm not actually going to do that because it gets very complex and mathematical, and I actually couldn't find one really good one to talk about. But the Silicon Valley Toxics Coalition did a sort of informal life cycle analysis looking at the three major components, design, manufacturing, and disposal, which is sort of the main topics I'll be talking about, mostly manufacturing and disposal. But the real truth of the matter is that, as they say it, PC is designed for the dump. What does that mean? Well, they have a short lifespan, as I'll get into a little later. It's a good thing that we get progress and we get newer and better things and faster computers and better capabilities. On the other hand, that's more and more things that are basically built for 3-4 years and then they have to go somewhere. Manufacturing, I'm going to get into a little later, causes pollution, hazardous waste, and then disposal most of my talk is how to deal with the disposal issues. So increasing obsolescence that I think we're all aware of, and we have a Bill Gates quote, which doesn't make him a bad guy for saying that. That's a principle of business, is that if you want to sell more of something, you don't want it to last too long. American business has been doing that for hundreds of years. We're familiar with Moore's Law, so the increase in the capacity and the capabilities of the chip and memory and the other components are increasing at an increasing rate. So in addition to the obsolescence, they're not designed for recycling in many cases. There's improvements to that, but they're made of hard to recycle materials, toxics that I'll be mentioning later, non-recyclable plastics in many cases, or mixtures of plastics that are, by virtue of being a mixture, are very hard or impossible to recycle. I know from taking apart and putting together computers, you have non-standard screws, you have surprise screws, you wonder what sort of driver you're supposed to use. There's snap-in plastics that break off that make it hard to put it back together. But basically, it's hard for an amateur and for a small shop to get a lot of different variety of these PCs in and be able to refurbish them and recycle them. Toxics in computers, this is sort of an eye chart. I won't go through the whole list, but there's hundreds of toxics in the circuit boards, small amounts, but you add them up, and that creates a big problem for disposal and for leaching of toxic and hazardous waste during the manufacturing process. The biggest bugaboo that started a lot of this issue nationally back in the early 1990s was CRTs, cathode ray tube monitors, which have 4 to 8 pounds of lead in them. And that led a lot of states, such as my state of Massachusetts, to prohibit the disposal of CRTs, either computer monitors or TV. And that's sort of the largest total amount of a toxic you would find in any component is 4 to 8 pounds of lead, because that's what protects you from the radiation in the CRT. But there are other ones. There's mercury, laptops and LCD screens, flat panel screens have a backlight that uses mercury. The mercury vapor is what creates the light. And so now we have a problem as CRTs are being phased out and being replaced by LCDs. And in many cases, people are buying more laptops now than desktops, that we have a mercury problem. Now, a lot of states require labeling on them, so you find a label on your laptop in many cases, or your LCD saying this should be disposed of properly. That doesn't say how, and in many cases you can't, but at least there's more and more labeling so people are aware of it. Brominated flame retardants that are in a lot of, that are in some PCs, some monitors, can create off-gassing of toxic gases that can be harmful when you're using it, and also create a disposal problem. So PCBs, there's a lot of toxics, and that's the basis for why this is a problem, obviously. The IT industry has an image of being a clean, pristine industry that's not like traditional manufacturing, but the fact is that there's a dirty underbelly with these toxics that need to be managed, and there are safer alternatives. So I'm going to give an overview of some of the impacts of manufacturing, and then I'm going to spend a lot more time in detail on some of the solutions. So one thing you look at for impact of manufacturing is how many raw materials does it use? What's the impact on resources? So there's studies showing that manufacturing one PC can use 1.8 tons of raw materials, well, about the same as an automobile. 240 kilograms of fossil fuels, which is almost as much as it used during its life, just to make the PC from the manufacturing process with all the components and the assembly and the plastics and the metals and the circuit board. And 10 gallons of water needed to make one chip. Well, that doesn't sound like much, but when you get 100 million chips being made, that's a lot of water, especially in California where a lot of them are made. And California has an permanent water issue because they get a lot of the water from the Colorado River and from out of state. Also, again, mainly in Silicon Valley, and this data comes from the Silicon Valley Toxics Coalition and the EPA, it's really not debatable. There's 29 federal Superfund hazardous waste sites from the decades of manufacturing of semiconductors, from those toxics and from the acids that are used to clean the circuit boards and to be used in the manufacturing process. Contaminated large amounts of groundwater. In addition to that, because of the toxics in the materials, in the PCs, the laptops, the circuit boards, in other materials, the LCDs, when it's thrown away, when it's in a landfill or an incinerator, that makes up about 70% of hazardous waste. So going on to the use of the computer, energy use is a big issue that most of us are aware of when we're concerned about uninterruptible power supplies and power suppression to make sure the power is clean and uninterrupted going to the machinery. But you've got a data center, you've got a large collection of servers or a lot of units, and you're creating a lot of heat, which is waste energy going out that has to be taken care of by the HVAC system. And so energy use is a cost issue, obviously, but it's also an environmental issue because all that energy has to be produced. How's it produced? Oil, burning gas, burning coal, or nuclear power. And each of those have environmental impacts. So a big contributor to the use of energy in the United States and across the world is IT, is IT machinery, because it's a voracious need and appetite for energy. Now, there's a lot of organizations working on trying to help us as individuals and companies and universities reduce our energy use. And I won't read this, but these are top 10 ways to reduce computing energy use. EPA has done a study showing that if everyone kept their power saver configuration on their computer the same as when they got it, the default settings where the monitor goes off after 20 minutes, something like that, or it goes on standby after 30 minutes, the hard drive powers off after an hour or whatever it is, that millions of BTUs would be saved throughout the country. A lot of us, such as me, change those because it's very hard to work on a computer when it's shutting down all the time. There's a whole industry looking at how can individuals, maximize their use of the computer while minimizing their use of energy. And part of that is because part of the reason why this is needed is that a lot of computers, PCs, again, talking about traditional PCs, desktops, are inefficient. The power supplies, the average is 47% efficiency. You can buy ones that are 80% or more efficient. That's obviously a major factor in energy production, in energy use. The chips, faster chips use more energy. As you know, they have to be cooled, and that also uses energy. So there's a lot involved with the manufacture, how it's manufactured, the design we talked about earlier, but also the use. So getting to the meat of the presentation, end of life. So you're done with the PC or the laptop or the CRT or the LCD or the smartphone or whatever. And the EPA estimated about 10 years ago that e-waste is growing 2 to 3 times the rate of any other source of waste, mainly because of the obsolescence and the increased rate of improvements accelerating the obsolescence. And 40% of the heavy metals in landfills in the United States, lead, mercury, and cadmium, come from electronic discards. So when I was at Clean Water Action and helped form the National Computer Take Back campaign, there wasn't much going on in this back in 1999. Now there's a lot more going on that I can tell you about, where there's places to go, there's recommendations you can pull off the shelf for how to do things better, and the manufacturers are now listening to trying to improve things. The other ugly underbelly that some of us may not feel we have much control over, and it's hard as an individual to deal with this, is a lot of the end-of-life, disposed, not used for their main purpose anymore. The terms are an issue sometimes when you get into talking about this issue. They go to China or third world countries in Africa, where it's a big business for kids, for small businesses, people in a street corner, people in an area of China, to take them apart. And these aren't pristine, white coat, medical, looking facilities like you see in Silicon Valley. These are people outside, heating up the circuit boards to loosen the solder, and then manually taking off the wires and trying to, reclaim the gold, or pulling out the wires. So it's a major scandal internationally that the national organizations working on this issue, called BAN, estimates that 80% of the used electronics in the U.S. goes to China, where it's the low-tech recovery is going on as a regular basis. And there's a film on this week you can get off the web from the BAN organization, and a lot of information on this that documents the health dangers it creates for the residents doing this. And they're doing it to make money and to make a living, but it's endangering their health, and it's polluting the groundwater in their area and despoiling the land. And you get waste all over the land. You get groundwater that's contaminated with the heavy metals and the cadmium and the lead and the mercury and the other toxic materials. So that's an issue that needs to be dealt with. The trouble is it needs a national law to deal with it. There's the Basel ban is a international treaty that the U.S. has signed, which deals generally with the transboundary transportation of hazardous waste. Then there was a separate codicil to that a lot of countries haven't signed, including the U.S., which specifically address electronic waste, saying that no electronic waste shall be shipped to a non-OECD, i.e. to a developing country as opposed to a developed country, because of the problems that have occurred, such as in China and Africa, from the developing countries, trying to make money from these discarded electronics and endangering their health at the same time. So there's an ongoing issue with that I'll get back to later. So dealing with solutions now, extended producer responsibility, or EPR, is the broad term for what needs to be done that a lot of countries and states in the U.S. have already gone to for electronic waste and other waste. And a little background. Right now, a lot of the waste is manufactured products, not just, if you go looking at products in general, not just electronic products, you go back to 1900, and most things that were thrown away, most things that people used weren't manufactured. Most of the waste was, food scraps, coal ash from the coal burning stoves that people had in their houses, and occasional bits and pieces of wood or steel or whatever that they were discarding. After World War II, there was an explosion of manufactured products that this lower, I can't get this thing to work, this lower chart tries to talk about New York City 1900, the US in 1960, then 2000, looking at the increase in products, manufactured products, which includes packaging. So with the explosion in manufactured products and then the waste, the packaging as well, which is sometimes can be 40% of the waste, and the products themselves, because of the planned obsolescence in other products as well, suddenly cities and towns across the country were paying for something that they had never planned on before, which most people assume is a regular service of a city or town, which is solid waste disposal. There's really no law saying that they have to do it, but it's a service they provide for local residents. So an economist, economic analysis, and I'm not an economist, but the economic analysis is you look at that as an externality of the product. It's a cost of using the product is the collection and the disposal of the used product. Is that external cost included in the price of the product? No. Does the producer of the product, think of that, include that cost when they try to figure out how to price the product or how to design it? No. So they're not concerned. I mean, this is a basic principle. They're not concerned with, is the product recyclable? Doesn't matter. Is the product toxic, so it'll cost money to dispose of properly? No, they're not concerned with that. So I'm trying to explain the principle very concisely. So extended producer responsibility tries to turn that around and say, hey, the price of the product should reflect these externalities. So therefore, there's an economic driver in the free market for the producer to do things better. And they're the ones who obviously have the most control over how the product's designed, or all the control, actually. And they don't necessarily control how it's collected and disposed of, but I'll get to that next. Now, extended producer responsibility was, the term was coined in the early 70s by Thomas Lindquist, who was a graduate student in Sweden. And the Swedish government adopted it soon after that as a guiding principle for how they would deal with waste and product management, as it's called. And Lindquist, he came up with the term in his PhD thesis, I think it was 73 or 74, and he looked at, if you look at the top table, he did a study similar to what the Container Institute did, and I provided more recent data than he had at the time. And he looked at, hey, what about the states in the US that have bottle bills? Let's say with a 5-cent or 3-cent or whatever the cent deposit, you get it back when you return the can, and then the manufacturer has to do something with the can. I'm not exactly sure how specific that is, but that at least gets it out of the cities and towns, and they don't have to pay for the collection and recycling. And you compare the 11 bottle bill states to the 39 bottle bill states, and you look at the total recycling. And you can see it's 61% recycling in total for the 11 bottle bill states and 24% for the non-bottle bill states. So he concluded, with the evidence similar to this in the 70s, that, hey, a manufacturer required system for collection works better than not doing that. So the two charts here are the Okay, stuff. We're talking about stuff. So the top one is what goes on before extended producer responsibility. The supplier of the raw materials goes to the producer, the retailer sells it to the consumer. Then the government is usually involved, local government, and they're collecting and recycling it. And in many cases, they may be recycling it, but it's not a complete loop necessarily, because some of it may go back to the supplier, but a lot of it goes elsewhere to incinerator, disposal, or being dumped somewhere. So at the bottom is the conceptual model for producer responsibility. You have the supplier, producer, retailer, consumer, and you have them complete the loop where they are involved as the producer. The producer pays money to the producer responsibility organization, which the industry doesn't want to call that. They call it a third-party organization. Whatever they call it, what it does is so they get money from the producer, and then they pay for the recycling and disposal. It can be either individual producer, like HP does only HP products, or Dell only Dell, or it can be all of them together if they think it's more efficient to do it all together. So the first country that adopted this was Germany for packaging, because they were noticing that in the late 1980s that packaging was overwhelming their solid waste disposal. So they set up a model just like that lower diagram, where they required the producers to pay for collection and recycling of their packaging and set up a separate system. And it was called the Green Dot Organization. So some brilliant PR guy came up with Green Dot as opposed to purple or red or something else. So it's green. And it was successful. And it reduced packaging by 14% during the same period of time. It increased in the US by 13%. So again, trying to compare apples to apples, having the industry pay for the collection and recycling. So not just paying for the collection and recycling, they're saying, hey, wait a minute, I'm paying $10 to have 100 pounds of this collected. What if I make it lighter? What if I make it some material that's easier, that it's less pounds, but easier to recycle? So EPR laws for e-waste, or electronic products, is what we're focusing on. But Green Dot was still the prime example, because there's a lot of time and more analysis of that has been done. EPR laws for electronic waste have been adopted all across the world except in the US, the US federal government. 20 states have adopted it. Let me go back to the world. There were 14 provinces in Canada. There's some South American countries. There's a number of Asian countries, including Japan and Taiwan. And the European Union has established the WEEE directive. And WEEE, and I'm not going to remember the full acronym. But basically, it's an all-inclusive, phased-in approach, and it applies to everything with a plug. So it's not just electronic, it's electrical. And so the EU is sort of a federation, and it requires the member countries by a certain date, I think it was 2006, to adopt federal laws, national laws that were consistent with it. But there's a wide disparity in what different countries have done to adopt it. But in principle, every European country does require the manufacturer of an electronic product, HP, Dell, Gateway, Lenovo, whatever, to pay for the collection and recycling of their discarded products. And so the U.S. companies, even though the restriction on hazardous substances law doesn't apply to them because it's only in Europe, they're selling to Europe, so you'll see a lot of ROS compliant stickers on things in the U.S., which is good because they're looking at those 100 toxics, and they're not prohibiting every one of them outright, but they're requiring that in certain cases that something be substituted with a safer alternative, if there's a study showing that there is, or that some things be phased out completely, because like mercury, as much as possible. 20 states in the U.S. have adopted EPR laws for e-waste. The people used to say there's 21, but California adopted one that's strictly a tax. All the other 20 states, including Maine was one of the more recent ones, in New York, require the manufacturers to set up a system to pay for the collection and recycling of their used products. California puts a tax on a product, a fee. It's like $8 for a computer or $4 for a small monitor. And then the money goes to a state agency that then pays recyclers to go and collect it. And there's been a study comparing the California system to the Maine system, which is more of the pure EPR that I described earlier, where the companies pay for a collective sort of collection points in the state, and then they divvy up, they determine how much of this pile is each product's responsibility, and they pay for, then they collect it and recycle it. And the studies show that the cost overall is much greater in California than in Maine, and that the collection rates are better in Maine than in California. That's one of the big debates, is how to do this. The California system is recycling, which is good. It's good to have more recycling and get it out of the landfills and hopefully keep it from going to China. And these laws try to have that as part of their requirements. But the Maine law also, in the other states that do it, is now suddenly pressure on the companies to say, wait a minute, we're paying X amount to collect and recycle these things. Maybe we should do something to make them more recyclable. And I'll get to that. So there have been studies showing that it does work. The chart on the right is showing the results after a few years primarily in Minnesota and Washington and Oregon, that the recycling rates have increased for electronic waste. One of the best examples actually of EPR working is the full extent of EPR, which is inverse manufacturing, which is what Kodak has done for years with their disposable cameras or their one-use cameras. And of course, that's a unique product where you're only getting the value. I don't know how much they're going to be in the market now with digital cameras, but this is the old film inside the plastic enclosure, and to develop it's basically a container for the film. So to get the film developed, you have to bring the whole thing back to Walmart or CVS or whatever. But so they thought they did the right thing to start with. They designed this whole product with the idea that, well, they're coming back, and every one of them will be made from recycled materials from the ones that come back, which only makes sense because otherwise they'd be throwing one away, then making a new one completely. And it's not a good business model. They figured out correctly that the best business model is to plan to make it from recycled components. And I've been advocating for this when I was at Clean Water Action years ago, and no one seems to join with me on it. But that's really where this all should be going. When they build a computer or a toaster or a refrigerator, the manufacturer should plan that they're going to get it back or the parts back and make a new one from that. That's your ultimate in terms of keeping a loop. When you talk about recycling, it's not one loop. It's a lot of different little loops at the end. That's one of the few examples. Also, some of the manufacturers of copy machines, Ricoh, Canon, HP, a lot of them, they don't sell them to you, they lease them to you. And that's a form of EPR where basically they're providing the service, but they're still responsible for the hardware. And that's in this scheme of things is a good way to reduce the waste and prevent, oh, the copier doesn't work, we'll throw it away, we'll buy another one. Well, in this case, the company saves money and Canon or HP saves money because they're servicing the copier, or they take it back and they take it apart and use it for other copiers. So there's been more interest in the last 10 years than there was before internationally in looking at these kind of models for businesses that are good for business. It's not just green, it's not just sustainable development or businesses. There's a cost argument, such as in a business and reducing the energy use from the server farm or from the computers. Energy costs money. So if you're going back to your universities or your companies or whatever, and you want to look at this issue, that's a good argument to make. It's going to save money. So packaging this all together, there are more and more companies going to providing take-back services. There are more and more companies looking at how they can make the product less impact environmentally. But there's a swarm now. When I started this 10 years ago, there were none of these. Now they're everywhere. Green PC purchasing guidelines, and it doesn't have to be called green. The EPA has the Electronic Product Environmental Assessment Tool. The Electronic Take-Back Campaign that I helped form 10 years ago has a beyond EPAT, where they're a little more strict in their requirements. The Green Purchasing Network, basically, you can find all these on the web. I didn't provide URLs for them, but you can find them easily. And the United Nations Environmental Program has ones that are more severe or more strict than EPAT. So what do these talk about? I don't have a slide with all the criteria, but it's everything we've been talking about. So you're a large organization and you're buying 1,000 PCs, or you have to have 1,000 seats, and you're planning a refresh. So who do you go to? Well, so you put a bid out. If you're a public organization or a big company, you're going to put a bid out. So what are the requirements you're going to put in? Well, you put in, does the company, have a plan? Will the company pick up and do asset management? Dell does this, Does it have an asset management plan? And most companies do this without thinking about it being environmental. It's good business practices. So one big component is, does the company, plan to take back, to collect them when they're done, and then hopefully include that as part of the price for replacing it. So you get a markdown price for replacing it because you're giving back their old parts. Something like that. There's a lot of different ways to do that. The other big one is energy use. Do they comply with the EPA recommended requirements for energy use, for energy reduction? What are they made out of? Again, even though the company's taking it back, it's a driver for the companies to have them more recyclable and less toxic. Again, a computer or a laptop or a LCD or a CRT or a smartphone is going to be toxic no matter what you do to it, but you want it to be less toxic. So I won't go through the specifics, and I'm not really an expert on the specifics, except to say that there's dozens, if not hundreds, of recommended guidelines out there. So there's a lot of places to go to see, boilerplate to put in your request for bids to try to get the best, less environmentally impact computers or electronic components for your business. Now there are people who argue what a green PC is, and Greenpeace, surprise, has a guide to greener electronics where they deal with this in very intimate detail. And there's a website, and they do annual rankings, and they look at things such as the phase out of PVC, polyvinyl chloride, which is toxic in its manufacture. There's arguments that it might off-gas toxic gases, and when it's burned, it causes, in an incinerator, it creates dioxin. So it's sort of bad any way around. And BFR, brominated fire retardants that I talked about earlier. So they're very specific in terms of what's it made out of. Is it using something that we know is toxic when we know there's a safer alternative? And it also talks about dismantling. We're all familiar with the difficulty in dismantling PCs and these non-standard parts in some cases, the different screws. And Hewlett-Packard did a study in this, and the Design for Recycling, DFRE, which includes, analysis of how to make it easier to dismantle, could reduce the dismantling time and save money. Especially, why are they thinking about that? Because they're the ones taking back the PCs in many cases, so they're dismantling it, or they're paying someone to dismantle it, and they don't want to pay more than they have to, obviously. So that's an example where the EPR driver, even if they're not required to, HP has been good. They have a voluntary program, and they're doing this in a lot of cases, and Dell as well. So there are things that can be done in this area as well to reduce the costs and make it more recyclable. Now there are people marketing a green PC, and I would put that in quotation marks because, relatively speaking, some might be less green or more green than others. The PowerMate Echo, it's been specifically designed to have the least possible negative impact on the environment. We'll see. And IMECO of Dublin, 100% biodegradable computer components. That I didn't verify these, so I'm just saying these are two claims so far, and the good news is, from an environmental perspective, is people are working on that now. And I mentioned the businesses now. Since there's been organizing by Clean Water Action, the Computer Take Back Campaign, Greenpeace, the Silicon Valley Toxics Coalition, on this issue that started 10 years ago, companies have started to offer free programs. When they started, it was mostly token programs. Oh yeah, we'll have something once a month or once a year, or will come to the Staples store, or will come to a regional solid waste collection center. But now they've got, now there are different versions of completely free take-back programs that when you buy the new computer, if you look at the paperwork in there, it'll say, you know, we will take this back, here's how you can do it. You know, and they might provide and there's no one way to do it. They might provide a label to go to UPS to send it back. They might say, call and bring it here. But most of the major manufacturers are doing that now. Sometimes free. Apple and Asus. There's some that are that require payment, which again is sort of counterproductive. Obviously, people are going to give it to someone to take back if it doesn't cost them any money. Otherwise, they pile up into people's basements and attics, which is what's been happening. And there's a couple of companies that don't do anything. But a lot of the manufacturers have been getting pressure over the last 10 years to do this. Clean Water Action and other groups led a campaign against Michael Dell, that including sending hundreds of thousands of postcards to his house that finally get him on board to at least pretend to address the question. And the evidence is that the voluntary program that most people haven't heard of isn't really doing much. That's one reason why when I was working on it with Clean Water Action in different states, we were leery about going to Congress because that's where the industry might have more clout to try to turn the whole thing around on us. So we had been trying to go state by state. And the argument against state by state is you get especially for a national or international company, is you get a patchwork of different regulations. And I agree. But we were doing that at the time back in the early part of the last 10 years when the companies were against it and we were fighting company opposition. Now HP, Dell, Apple, they're all in favor of it, they say. But it hasn't passed in any more states in the last few years because of other issues going on. So it's better to have a national law like they have in the European countries or South America or the Asian countries, but we're a long way from getting that in the U.S. So in the meantime, there'll be more and more state laws that are being proposed and may pass in the next few years, which from an environmental perspective will be a step forward. And then after enough of those happen, we were hoping that there'd be a federal law that would basically mirror what a lot of the state laws did. In Massachusetts, where I've been working on this, we've been unable to pass the law. I've been working on it for 10 years. People think Massachusetts is a liberal state. You would know that from lobbying at the State House, which I've done. It doesn't seem very liberal at all, on environmental issues anyway. It's not really a big driver for how politics is done in Massachusetts. Maine, I helped pass it in Rhode Island and Connecticut, and then it passed in Maine. And then we took a model bill at the time that the National Computer Take-Back Campaign put together, and we adopted a similar law in Rhode Island and Connecticut. Maine went a little differently. I mean, it's a bigger state, a lot of empty land, so they took a different approach. But we've been trying to be consistent as much as we could. But there are a couple different models on there on how to do it. And again, there's no one right way to do it. But I agree, if a large company has to comply in a lot of states, it makes sense if they had similar requirements to meet. But so that's a still ongoing battle. That's how that's going to be resolved. Purchasing guidelines. The EPEAT program has been around for a while, and the EPA estimates that it saved a lot of electricity, prevented a lot of discarded waste from going to landfills and incinerators, reduced air pollution, reduced water pollution, reduce toxic materials, again, by those criteria that I talked about. I'm building a PC to be used in, I don't do gaming, but I'm building a high-power PC in a small case, so I'm looking at keeping the temperature down. And so I'm looking at what processor to use, so you look at the wattage, and if I can get a processor that's as powerful as I need, that's 90 watts as opposed to 135 watts, you pick the lower one. So there's a lot individually we can do to save money. But that's also part of these things. And because of the environmental driver for looking at these criteria, that's help for all of us. We don't have to try to figure it out for ourselves necessarily, but if we're thinking in that framework, we can say, we're building a new computer, we're buying a new computer just for ourselves or for a company. You could pull the EPEAT guidelines off the web or Google for green purchasing guidelines or any combination of words similar to that, and you'll find a multitude of them. But again, it's the basic principles I've been talking about that aren't rocket science. Energy efficiency, lower energy use, RoHS compliant, which are RoHS, the European requirement. So anyway, so I'm basically concluding, while IT benefits society, there are costs. We in the industry should be aware of them and do what we can, I believe, to minimize them. You can never eliminate them, but like anything else. But the good news is there are people who have been working on this for a while, including industry and the government. So there are places to go for more information and to guide you in making it less environmental impact, but also saving money. I could have given a 3-hour presentation on this. I try to keep it as an overview. Apple has done a lot of analysis of all people. They were late to the game actually in the EPR, but they have a great analysis on their webpage looking at their environmental footprint, their carbon footprint, which is the energy that's used to make their products and the energy that's used to run them. And so they, like everyone else, probably have more to go, but at least you now have a marker to say, here's what our footprint is now. Then you can check, a couple of years from now and see if they're getting better. Other companies are doing that to some extent, but not as detailed. They've got pages and pages on their website of the footprint and discussing, I believe, how they're going to try to improve that.
It's like one of my problems with them is they'll say, every component is recyclable. Well, it's not. It's only to a certain extent because, for instance, the molecular cohesion of the plastics, those break down after each recycle, and so there are a limited number of recyclings you can do on that. And that's one of the things that really gets to me about these, that they continue to recycle and everything's recyclable, only for a certain number of times on some parts.
Right. One of the studies, I brushed over this earlier, looking at the successfulness of EPR, it was another country, for driving product improvements, is mostly before the law took effect in, I think it was Taiwan or Japan. Suddenly all the manufacturers in that country said, wait a minute, we're going to be, and they did a redesign. But there's very little evidence. I mean, they can't do anything about a product that's already in the market, obviously, for redesigning it. But if they do what Apple's doing and they look at the specifics and they use that as a guide for the next new product, well, yes, you get a new product and you're still obsolescing the old product, but the new product will hopefully have a lesser footprint. So we're not going to get around the problem of progress where we got the iPhone 4 now, and 5's going to come out, then 6 and 7, then 8, then 9, and then everyone's going to be. There's really no way to reuse an old iPhone, I don't think. Although, yeah, okay, but you could donate them. What people do with used PCs and other things, they donate them to a nonprofit or a small group that doesn't have the money. That's limited, but there's a way you can do that. Question back there. Oh.
Yes. We can always vote with our wallet. What companies should we be avoiding in terms of minimizing our environmental impact?
What was that question?
What companies should we be avoiding?
Oh, I'm not going to go there. I'm not going to go there.
Right, thank you.
I do warranty support for a number of the companies I've talked about, so I don't want to. I'm not. They all can do better. I only point out Apple because they're the only one I found with that very detailed information on their page. Look here. Let's look back here. Oh, end of slide. Hang on. Acer and NCEC don't have any ongoing take-back program. So trouble with that is I like Acer. I mean, the products are probably good, but this slide's only a few months old, so that may have changed. So there's no one answer now. You have to look at the question, what's important to you? Do they offer take-back programs? Are they RoHS compliant, which I'm sure they are? What do they have on their website? You have to do a little research. There's no, and it's going to change because there's more pressure on all of them, all the time. Question? Oh.
So these take-back programs address all the new hardware that we're getting. What do we do with all the obsolete hardware that we have lying around at home?
That was a big issue. Well, and still is a big issue with requiring a take-back program. You get two problems. One is what's already out there. So the issue isn't redesign, obviously. As I said, it's how do you responsibly collect and take it back, and that's clearly and recycle it. or reuse it or refurbish it, whatever. And that's clearly the responsibility in the framework of the laws for the manufacturer, either together or individually, together with other ones or individually. So that's the easy one. The other one is orphan products. So you got a company that made computers 10 years ago, and they're out of business now, but they still have hundreds of thousands of units out there that people, for the most part, are stockpiling in their basement or garage or attic because they paid $2,000 for this thing back in 1989 or 1995, more likely, and it's expensive. They don't, and most people have a vague idea that there's toxics in them, and they don't want to just dump them. So there's hundreds of thousands, if not more, of these things all across the country that are just, people are just sitting on. Mainly because a lot of towns pay for someone to recycle them. So most of the laws that have been adopted in the US have a provision for orphan products, where basically all the companies that are in the market now pay for the collection of orphan products based upon, in most cases, the company's share of the current market. The other way to do it is their share of what's being collected. So those are the two questions. But the bottom line is it's part of a take-back law is you require that they take those too. Because otherwise you're not really addressing that part of the problem. And the companies usually agree with that. For some reason they pick one scheme over another, probably depending on how great their market share is as compared to their share of what's being disposed of. But that's been a big sticking point when we started to design. I was in a group with EPA back in the early 1990s where we tried to design, early 2000s, I'm sorry, where we tried to design the program from scratch. And that was a clear issue from an environmental perspective is we have to take care of what's already out there. Question?
I just wanted to respond to the how do we vote with our wallet question. And it looked like Greenpeace had done some work on that. And instead of saying which one should we not support, maybe which one should we support,
yes.
Looking towards the green end there.
Yeah, they do a annual rating. I think Nokia was #1 in the last rating, or they were the last one. But right, so check Greenpeace's rating system. You're right. Any other questions?